Welcome to this section of the course where we will be solving equations to find points of intersections of parametric equations. So we've been told in this example that x and y are defined as such, but we weren't told about the value of this constant a. And in fact, the question does give us the diagram for the shape of the graph, but it's asking us to calculate the value of a given that the parametric equations go through the point -4 and 0. So -4 stands for the value of x, and at that point where t will give us x to be -4, that same t value will give us a y value to be negative to be 0. So x value is -4 rather than 4, and this t, the same value of t, will give us y equals to 0. So we look at the two equations here. X's definition has two values of t, so we cannot make t the subject of this formula very easily because of the t square of t. But the value of t is more easily found if we rearrange the equation of y. So what can we do? We can solve this, take value of y to be 0 and solve for t here. So what we have is 0 equals to a, and the value of t is the unknown that we are looking for, and we have 8 added there. So we can divide both sides of this equation by a, and that eliminates a from this equation. In fact, we'll have t cubed, t cubed is going to be, and first of all, dividing by a will give us 0. So -8 will equal to t cubed, and taking cube root of -8 will give us t to be -2. Now that we found what the value of t is at this intersection point, then we can use that point, and we know the value of x is -4. Therefore, -4 equals to a times the value of t that I found to be -2 squared plus another t, but I'm just going to write -2 because I'm adding a negative number there. So solving this equation for a, we'll take the -2 to the other side. So adding 2 to both sides, we'll have 4a equals to -2. Therefore, dividing both sides by 4 will give us a to be a -1/2. Okay, so let's look at the next part of the equation, next part of the question. So in the next part of the example, we were asked to find the coordinate of the point A and B where the graph cuts the y-axis. So what's the value of x on these points? The value of x will be simply 0. So we know for sure that x will be 0, and we need to calculate the value of y's. So we go back and to our original equations, and we're going to take the value of a that we found to be -1/2. We substitute this into the equation for x so that we can figure out what y is. We can factorize one of the t's here. So if we can factorize a t out of this equation, and we'll have -1/2 t plus 1 inside the bracket. So either value of t is 0 or the value of t is +2. Then we go and we take these two values of t and substitute them for y, so that we would figure out one of the values for y is -4, and the other value of y will be -8, and they're both negative, and that's confirmed on the graph. Okay, so that solves this example. I'll show you another example next. we will have, in this example, x equal to t squared and y is 40. So we are told that function also meets the curve x plus y equals to 4. So in our case, this is another equation that we were given. You can call this another parametric equation, and we want to find the intersection of these two parametric equations. So we can simply substitute the value of x and substitute the value of y here in this equation. And what you notice is that we will actually have an equation defined in terms of t that is looking like a rather quadratic equation, which we can factorize and solve or complete the square. Either way, we will have two answers. The roots of this equation, when that equation is equal to 0, the answer is t equals to -2. Okay, so we can substitute back this -2 into value for x and value for y, and we get the x and y coordinates. So x coordinate is 4 and the y coordinate is -8. In the next example, we were told that cos t and x is cos t plus sine t, and y is t minus pi over 6. And we are asked to calculate the point where this graph meets y equal to pi square. So what you notice from the graph of this equation is that the bounds for t will make it make x value go only to -1 here, and the y equal to pi square, value of pi square is 9.86. So what we are looking for is where does this graph really has the value of y equals to 9.86, basically. So we are setting y value equal to pi square here, and the equation for y is defined in terms of t here. So that's what we are doing, basically equating it to pi square. We can take a square root of both sides there, and we will have plus and minus sign in front of it. Makes sense to put it in front of the constant pi here and solve for t. So adding pi over 6 to both sides, we will have two answers there. So then we can actually look at the range of values. We discard the fact that pi -5/6 pi cannot be within the range, because the range of t is bounded by -pi/2, and we only need to substitute one of the values for t into equation for x and equation for y. Substituting 7/6 pi for x will give us this answer, and we already know that well. We started with the fact that y was equal to pi square, so we don't need to actually do any substitution there. Okay, so in the final section of this example, we were asked to calculate what is the intersection of what are the coordinates of points A and B where the graph meets the y-axis. Now A and B are up here, A and B. Okay, so these 2 points are what to find the coordinates for. Obviously, what's the value of x value for A and B? Because it's on the y-axis, x value is 0. So what we are going to do is substitute 0 for x here and solve for t. So cos of t plus sine of t is 0. One of them goes to the other side and becomes negative. Then we can divide both sides by uh, negative cos, or rather just cos, and that would leave a -1 behind. So we'll have sine t over cos t, and as you are aware, that's tan of t. Therefore, we can take tan inverse of -1 to get the value for t. Now, tan inverse of -1 is negative pi over 4, and that answer is within our range. Yes, we can check. It is within the range for t, and has two principal values at every 80 degrees of pi. So the alternate answer is adding a pi to this fraction. Adding to negative quarter will give us 3 pi over 4. So these are the two values for t. We were asked to calculate the value of coordinates. So what we need to do now is substitute those two values into y equals to t minus pi over 6. So I'm gonna use the next slide to show you the calculations there. So substituting these two values into the formula for y, one of the answers comes out to be 25 pi square over 144, and we pair off both of them with 0 for x because we know value of x will be 0. Okay, that's this section done. So next section is application of parametric equations to real life problems. See that?